to our live stream. Today I'll be talking a bit about our Masters in Neurotechnology. This is part of a new series in MetaPilot Academy where we give a glimpse, sort of an overview of the different programs that we have, answer any questions that you guys may have. Um, so the first one is going to be focused on the Masters in Neurotechnology. I'm Dr. Dana Dick. I'm the founder of MetaPilot Academy. And I just want to take you through the idea, the history of the program, where we stand, and our perspective on the industry. So, some background, I am a neurotechnologist. My background is in neurotechnology. My PhD, I focused a lot on animal research, particularly microscopy, two-photon microscopy in awake mice, and electrophysiology. So we were patch clamping single neurons and trying to understand the connection between action potentials, dendritic spikes, things like that. Later on, I took an interest in building VR setups and working on spatial computing in the brain. I went to Norway. And then from there on, I moved to the US for a while, learned a bit more about how that works in the Drosophila brain as well. So at some point, and this is the interesting part, that at some point in my career, I felt like this is all extremely interesting. Um, but what I would like to see, especially with this type of neuroscience, and probably some of you are interested in the topic, but just listening to me talking about it, it's very niche, it's very particular. So you're also probably thinking, well, what impact does this have? How does this impact me personally? I mean, these input output computation in single neurons, how do these impact the world, right? Industry. So as a neuroscientist, I started to ask that question myself quite a bit. And then I realized that there was no program that is designed for people like me. So if someone is passionate about neuroscience and neurotechnology and all of these things, but also wants to have an impact in the neurotechnology industry or wants to build technologies related to the brain, there was just no path for us. There was either pure academia and becoming a professor and a researcher and taking the publish or perish route, or I guess some of us went into clinical work, but this is neurotechnology only to some extent, right? It's not actually building the technology. And so towards the end of my PhD, the first neurotechnology companies appeared. So this was long before Neuralink, but I would say in my short time working for a VC fund with the focus on neurotechnology, there was definitely a lot of appetite, starting with Silicon Valley and now more so in Europe. European grants are targeting this very heavily, as I'm speaking as a neurotechnology evaluator as well. And yeah, the landscape is changing in neuroscience, I would say. It's not as predefined as it used to be, and it doesn't have to have the structure that it has. So I'm doing this first presentation by myself, really because the Masters in Neurotechnology is kind of at the core of MetaPilot Academy and our efforts. A lot of the things that we do are around that, and I'm trying to explain also why this makes the program unique and what was our thinking behind it. So I guess you can see my slide. So MetaPilot Academy has one campus in central Barcelona. This is Plaza Universitat, and on the right of it, you have the main campus of Universitat de Barcelona, the main public one. We started out as a private university, so focusing on bachelor's, master's, PhD programs. And our idea was initially we connect with the top corporations and tech companies that we believe are impacting technology in a very meaningful way. So companies like Boeing, right, or Stellantis, these are making a huge impact, and they are, to some extent, they're a big part of what the industry is. So the aim was to train the generation of tech leaders, and this is something that has always interested me. I was more than just a typical academic scientist. And being in Barcelona, I find that a lot of people were interdisciplinary before becoming really good in their field. Also, because in order to advance a field, you have to be able to see things differently than all of your predecessors, right? If you see things in exactly the same way as everyone else did, then you'll probably fit in. But will you be extraordinary? That's a different question. Anyway, so what do you think is the connection between neurotechnology and mobility, biotech, aerospace, defense, all these things? Some of you have never made that connection in your mind. Some of you are probably a bit afraid of it or find it a taboo, but haven't. If I were to ask you now to articulate that, where that fear comes from, you'd probably have trouble with it. So we're gonna get into that, into these connections, into the ethics, the philosophy of it. But first, I want to make sure that we understand what we're studying. The idea is to have the courses taught not by consultants or people only in academia, but rather to have the top researchers teach alongside the top tech leaders, right? So having people from Boeing, Stellantis, US Air Force, for me as a neuroscientist, it had such a big impact on my life and my way of thinking. Being able to speak to someone who excels in a very different field from mine, um, it's been incredible. I think maybe that's probably the biggest take-home message that I got out of this. The ability to be really good at something has a lot to do with the ability to see way, way outside of your field. So, speaking of seeing outside of our field, why we're building this? Why is neurotechnologies even happening? Why are billions being invested into this? So, the reason is also, as you've seen, you're probably watching the news, there are trillions of dollars being invested in AI and tech funding in general by 2030. A lot of it is coming from the Middle East towards the US and also towards Europe. It's complex, right? Our relationship. But that wave of investment is changing the structure of careers. They are not exactly the same as before. There are tech layoffs, but there are also new opportunities, right? So while things are kind of changing, we're trying to find a structure that makes sense. Obviously, thousands of tech jobs have been replaced last quarter. A lot of these positions are replaced by people who are comfortable orchestrating many layers of agentic AI, but also who understand when it's time for them to intervene personally, right? Because not everything can be vibe coded, as some of you know very well. Um, you cannot really vibe code the software of a medical grade device or of a defense grade device or of an aerospace device, right? When you're in a plane, you want to make sure that it's flying. You want to make sure that the person is really an expert. So it's a bit like that. First, the painful statistic is that 85% of neuroscience researchers do not remain in academia. And that's kind of why I wanted to build this program. There are some neurotechnology masters out there. But what happened was, and what happened with me, is that they kind of leave you hanging. You're either still operating in this exact frame that scientists have been operating in for the past 50 years, or there is no other known way, right? You have to figure it out. So when I started Neurobotics, when I started the academy, I had to figure out how to talk to an investor in a way that is acceptable for them, how to be convincing in a room, how to give a talk, all of these things. Um, so 85% of neuroscience researchers do not remain in academia. The idea in my head is to bring the best in neurotechnology and connect them also with the top labs, the top clinics, companies, etc. I could argue that companies like Neuralink started the marketing for what neurotechnology is, but we are now just beginning to figure out what high quality neurotechnology is. As in, well, I would define it as a science that gets closer to the truth of how the brain works rather than further away from it. So the market. Now you're probably wondering, finally, I'm getting at what does this have to do with defense, aerospace, and all of these things. Um, there's some idea. So as we work with different companies, and I mentioned the ones that we have as of now, we're getting an idea of what positions will be needed if we have something like a tech force being built currently across Europe, across the US, and everywhere. Then we are looking again at people that are able to work with AI when needed and to orchestrate it, but also who are able to completely disconnect from it when their expertise is required. And generally, they have to have that expertise completely separate from the AI expertise. The AI expertise does not replace the knowledge of a medical doctor or that of a pilot. It should be obvious. So while we will still have our typical pilots, right, we will also have people that orchestrate layers and layers of drone swarms, for example, drone and robot teleoperators, as there will be teleoperators for for surgery robots. So this is just to kind of give you an idea of also the salary range of these positions and what they mean. And I'm looking at this from the perspective of careers talent versus what is available, because I want people to have that perspective. When I started studying philosophy or neuroscience, I kind of studied the topic for the sake of the topic. But I know that many of you, at the end of the day, I mean, a big part of the reason why you're getting a good education is because you want to have a good career, one that combines your best strengths with something that excites you and that is helping you, contribute to the world in a meaningful manner. So that is kind of a combination of a lot of things. So, for example, if we work with the company and they say, well, we would need to see more machine learning in the way airspace control is being done, and we want to have that implemented gradually with this type of code into our legacy code, then we would try to introduce more of that into either into our curriculum, or we would definitely learn to train our students before they graduate on that specifically, right? Same for synthetic data, or maybe people in medicine need to learn sales, or they need more physical training. These are things that we're kind of following together with the recruiters that are a very interesting source of knowledge. So around that, if any of you has questions, I would be happy to take a break and discuss. I know that we've already went through this. Just a second. All right. So back to this thing. So we're talking about curriculum, virtual reality, space control. So some of the professors and mentors, as you can see, we're mixing up high-level researchers with people that are in leadership positions in tech companies. This is not by mistake. And it's also related to the fact that this is our core team, also some people in Barcelona. What I wanted to say is we're using AI to understand from our network of 50,000 people where you stand, what you're building in a particular niche, and who it is that you should be meeting. And I very much wished that this was presented to me at that age. I didn't know how to articulate what it is that I want to do. I was excited about neurobiology, very much so, but I also was excited about the potential of applications in humans specifically and how this affects industries like mobility, robotics, aerospace, and defense. So here we are. And it took me a really long time to understand how, as a neuroscientist, I could do anything that is of interest to someone working at Boeing, for example. This is just an example of a company, let alone in defense. So, now to the point where we are now securing all of these defense grants with neurotechnology. It's not just good for us, but it's good for the field of neurotechnology to be considered in this way. Um, and I certainly could not have achieved that without the mentorship of these people. So just to kind of give you an idea. And this is not the only field. I mean, neurotechnology and defense and aerospace are not the only fields that were far apart and are now coming together. They were initially more connected by the DARPA programs in the US. These have been discontinued, but then Europe picked up the slack and is now investing very heavily in neurotechnology, especially from top level labs. So I mentioned the AI that connects you to the right person at the right time. So if you have a very unformed idea, which could be the beginning of a brilliant idea and project, if it's really not clear what your technology is, the differentiation, the traction, then you should probably not be speaking to a senior executive, either at a company or an investment fund, right? This is a very good time to be speaking to someone who wants to mentor you at this very early stage. That's a different kind of person. Back to the master's. So the idea is you graduate in Chambord Palace. We have this arrangement with our partner university that offers the degrees. And yes, the Chambord Palace is the second largest palace in Europe after Versailles. And of course, you can also get your diploma notarized. So to make sure that it's recognized all over Europe. This is another discussion with diplomas and recognition of diplomas. It is an issue in the US, in Europe, all over the world. And we're trying to implement QR codes on the diploma that make it easier for people to connect them with the person's ID, and make sure that they are certified wherever they go. But it's an ongoing process, and we're working also with public universities to get that done. Now, at the core of it, because I've been talking about industry and careers and all these things, it might sound to you like this is a bit pragmatic. It's not. Um, so first, the modules of the neurotechnology program, which by the way can be in person this year, in Barcelona, and here in Barcelona we work with labs from all of the public universities, depending on the focus, right? And soon we will announce our other neurotechnology programs, the PhD, the postdoctoral, and so forth. Um, but so you're going to have access to our simulators that combine biometrics, elementary neurotechnology, I would say, and advanced analysis. So in the first stance of the program, you're going to learn what is a meta pilot. You're going to have a career progression template. So you're going to think 30 years ahead where you should be. Learning basic finance, very important in a master's. Some early mentorship sessions, orientation, meeting your colleagues and professors. In Barcelona alone, we have this group Techies that maybe some of you are joining from. That one alone is 8,000 members. So a big part of this master's is to really be social. Um, the core of it is going to be the neurobiology and neurophysiology. It just so happens that Barcelona is the place where Ramon y Cajal did most of his work of discovering the field of neurobiology. So very exciting stuff. But basically, brain anatomy, cellular structure, action potential, systems physiology, neurophysiology in brain and disease. You're going to learn cool things like Alzheimer's, Parkinson's. Um, Probably the neurobiology is the most important one, and it will be heavily examined also throughout the entire program. The idea is not to make you memorize the entire Candel book, um, or to scare you with exams, but it is so that you have a good enough structural understanding of the brain so that you are able to build meaningful technologies that wouldn't immediately make real neuroscientists cringe. This is important. Data analysis in neuroscience, obviously you're going to learn how to program, so MATLAB and Python. This is advancing fast, obviously, and as I mentioned earlier, there are some fields in which vibe coding really doesn't work. This is one of them. When you're dealing with brain data or neurosurgery data, you need to be able to write code yourself and understand where it is wrong. If you start with the idea that Perplexity or GitHub Copilot is already a better programmer than you, then you are going to have problems, taking charge of your own research and the understanding of it. Neurotechnology and brain-machine interfaces, my favorite one. I think this is definitely the future. I know some of you are excited about Neuralink. A good understanding of neurophysiology and brain-machine interfaces is going to help you understand the difference between a groundbreaking Nobel level discovery in brain machine interfaces and one that is basically a gimmick. It's very tempting to believe that you know now that difference, but there is a reason why people go through med school normally to learn neurobiology. So here it's really important that we go through all that. Biomedical imaging, optical techniques was probably one of my favorite courses. Understanding lenses, lasers, all of these things, building one from scratch. Again, a mechanistic logical understanding of these elements is going to help you build good technology. Digital twins, spatial computing, that's pretty much our core focus when it comes to research. This is where we got most of our grants on. Biometrics, neuro cybersecurity, and biohaptics. When I speak of neuro cybersecurity, I don't know how many of you have read Neuromancer. If you haven't, I highly recommend it. So the foundations of neural and spatial computing, invasive brain-machine interfaces, haptic interface design, there's so much to be built here. And to make a connection with defense, just consider human in the loop models alone. Then neuromorphic systems, neuro-inspired AI. Again, here, I wanted to be careful because technically all neural networks are neuro-inspired AI. The purpose of this program is to teach neuroscientists to be good technologists. So when I say neuro-inspired AI, don't assume you know. There's a reason why you have to learn all of this. What spiking neural networks are, they have nothing to do with ChatGPT. neuromorphic hardware architectures, bio-inspired AI. And so you see how it goes back into the neurophysiology. You will have an understanding of whether something is neuro-inspired or not based on your level of understanding of neurophysiology. Now, finally, only after we go deep enough through the neurobiology can we talk about neurotechnology innovation and entrepreneurship, from clinical applications to translation, medtech, biotech, commercialization strategies in neurotech. This is very important. So we're going to work with some of the bigger companies that have succeeded in neurotechnology. But again, the aim is to be groundbreaking. It's not to imitate a model that already works, right? And in order to avoid mistakes, as a neuroscientist that has gone into business, I highly recommend understanding financial modeling. I have seen very talented neuroscientists that, when asked about their numbers, their unit economics, and how exactly they're going to make money and create a return on investment, were completely unable to answer that. And you see, this is kind of a core requirement if you ever want to raise funding for anything. Neurotechnology, whenever it goes outside the realm of pure science, of it being done for the sake of science on taxpayer finance, then you need to know financial modeling. You need to be extremely comfortable with being asked what your numbers are and why, and what is the logic, and how exactly you make money, and how you give your investors a return on investment. Um, and that brings me to scientific and business communication. Some of us have been taught that this is soft skill. It is not a soft skill. A soft skill can make your or break your investor meeting for a very large sum that will literally decide your entire career. And it can make or break your life as a founder with your teammates. It can also make or break your entire personal life. So do not take it lightly. Communication is absolutely vital. The way you communicate, the way you learn how to manage yourself, to get your point across when you need to, and to not just be passive while also knowing how to manage yourself and others. Storytelling, pitching, presentation, and essentially learning how to not just be a robot. So these are some of the things that you will learn during the neurotechnology program. And as opposed to many theoretical masters, you need to deliver. So, and that's, by the way, one of the things that a lot of neurotech companies are looking for, people who deliver. So first, you'll be doing a lot of mentorship hours, and we will decide together what kind of guidance you'll be getting and where. And a lot of direct mentor. There is an AI coach training that will work with you on the entire coursework, and make sure you're up to speed. Then there's training via the Meta Pilot simulators, there's lab visits, there's internships, either within labs if you're trying to acquire data for your project, or something else, which brings me to the capstone project. So you should come up with something that is field changing in neurotechnology by the end of this program. This is the purpose. It's not a copy of something that already exists. It should not be a gimmick or something that is scientifically weak. It should be something that is really exciting for yourself and for everyone else who is listening. And that then brings us to the job placement week. So that's going to be 2 weeks of hardcore networking. You'll be presenting on a stage. There will be investors and recruiters coming. And then there's going to be one large thesis of approximately 100 hours. Now, with the thesis, we know that a lot of people do use ChatGPT, and it is very tempting to do that. However, a big part of the program is to make sure that you actually read the papers rather than just quote them, and that you develop a real interest, a real passion for this, also based on that deep understanding and an appreciation for what was done already in the field of neurobiology. Okay, so I think close to the end. Oh, yeah. So just the admission process at this point, there'll be a discovery call. Obviously, you'll be sending your documentation, your grades, your references, and then you'll be getting the feedback from myself and the board, and then a registration process will begin where there will be a discussion. And that's it. If you guys have any questions, I would love to know. Let's see. Very interesting. Who is this for and who is it not for? Well, I would say this is for anyone that's interested in the field of neurotechnology and what's happening in it. Again, I give Neuralink as an example. I've seen neuroscientists being fascinated with Neuralink without really knowing what the company does. And then I've seen people from outside neuroscience being fascinated with it, but somehow thinking that, they're not in a position to comment. I think anyone that is interested in the brain um, should should listen to this and should think about it. I think, as you might have noticed, most of the neurotech companies aren't only looking for neuroscientists or neurobiologists or psychiatrists or medical doctors. In fact, many of them are looking for engineers. They're looking for people who are extraordinary at sales, at storytelling, who are very good at operations, at people management, at finding the right talent. So, with neurotech, as with any other field, don't think it's just that. But if you do end up working, let's say in talent in neurotech or in investment, whatever it is, that excitement and that curiosity about neurotechnology, even if it doesn't have to go as deep as a medical understanding, you don't need to get to the level of being a neurosurgeon to have a curiosity about the brain. So that's kind of what I would like to end this with. Great question. And yeah, if you have any other questions, feel free to reach out to us. And it was very nice to chat with you today.